to lesson 10, simplifying expressions and polynomials. In this lesson, you're going to look for a few things. One, that we can use space to accurately simplify, that we can identify sets of like terms to combine them. So that's going to be a big part of it. Can we recognize them? And adding and subtracting coefficients, leaving the variables. So when we see them, can we add and subtract correctly? And is our final answer in standard form, meaning it is arranged in order from greatest to least degree. So let's try it out. In this first part, I just wanted to make sure that these notes made sense so you could read them out to yourself. But for standard form, we want to really make sure that they're in descending order of exponents. So looking here, usually we're going from left to right. Anything that has a variable is in the front oftentimes. And here, that's why the 2x comes before the 7. Looking at example 2, you have two variables, but notice c to the third power is bigger, it's a greater. So I put that in first. So that's a greater degree. And in the second one, because this b has a variable and this one doesn't, that's why I have the ab squared. It has a greater degree over here. So this first one is a third degree, the second one is just a second degree, and this one has no degrees. All right, so that's what we're looking for. For like terms, again, we're looking for variables raised to the same power. So for example, if I have 4ab and 2ab squared, I cannot add these up together because they are not the same. However, if they both had ab squared, then I could add them together, and that would just give me 6ab squared. Okay, but I could not add them if I had 1 squared and 1 was not squared. Nope, these have to stay separate. Okay, so we're going to do some practice with these and watch how I demonstrate my criteria for success in my work. Okay, with this first example, I'm looking at my two terms and noticing they are like terms. They both have x to the second power, so they are like terms. So I can add them together, and I'm only adding the coefficients, 11x squared. So only the coefficients get added. In the second one, I'm looking again, and they're both x, y to the second power, so these are like terms, so I can add or subtract those coefficients. 10 minus 15 would be negative 5. X, y to the second power. All right, so hit pause and jot this down into your notes. Okay, let's simplify this longer expression. It has tons of terms in them. So I have 2x plus 5 minus 3y minus 5x squared minus x plus 100 minus 19y. All right, that's a lot. So I'm going to use my highlighter to identify any like terms. I'm going to start with the 2x. Do I see any more x to the first degree? And I do, right here. The minus x. They're both to the first degree. Okay, let's see what else. I see negative 3y to the first degree and negative 19y to the first degree. So I can put those together. And here's another variable, 5x to the second degree. All right, so the 5 and the 100, they're both whole numbers. I'm just going to leave those there. And so I'm going to rewrite this, grouping the things that I want together next to each other. So here's 2x minus x. So the yellows first. Negative 3y minus 19y. They're together. Minus 5x squared. And let's put our numbers together. Plus 5 and plus 100. Now, just so you can see these were the same. So I'm going to add these two together. So 2x minus x leaves me with just 1x. Oops. Here we go, just x. All right, let's look at my blues. So negative 3y and negative 19y. I'm going to add those up together. I actually have negative 22y y. So it is subtracting. I just know they're both negative. So in my mind, I have more negatives. And here I just had negative 5 to the second power by itself. Negative 5x to the second power plus 105. All right, so I've combined all my like terms. I can't simplify that anymore, but I do want these in standard form, meaning I have to take the largest degree, which would be the negative 5x squared. That's the largest degree. And now I can go plus x minus 22y. They're both to the same degree. They're both 1. Plus 105. So that is my final answer for this one here. Now, if you had negative 5x squared minus 22y plus x, would that be okay? Yeah. Because they're both, the x and y are both to the first degree, I don't think it really mattered which one came first. All right, so hit pause and jot this down into your notes. And we're going to do one more example together. Okay, well, here we have 2 examples. Let's start with the first one. I'm going to start by just, again, identifying any like terms. Notice how I'm doing negative 3c to the second power. I'm highlighting that as well. Okay, and now I can rewrite these. Okay, just so you can see color-wise, these are the same. They're like terms. These are like terms. And this is a like term. All right, so the first one, 4c minus 3c squared, is just going to leave me a 1c squared, or just c squared. 6 minus 2 is 4, so plus 4c minus 3, and it is in standard form, starting with the highest degree, a second degree. So this is my final answer. And we'll do the same thing with the second one. Again, I'm scanning to just ensure that I have like terms. So this one here, r to the third power, r to the third power, r squared s, r squared s. And the last one, these are just whole numbers, even though that has an exponent in there. All right, so let's rewrite this. 5r to the third power. Okay, and now we're just going to simplify. I'm going to start with, these are like terms. These are like terms. And these are like terms. Okay, so 5 minus 1 is just 4, so 4r to the third power. Negative 1 minus 3 is negative 4 r squared s. And now here's the last part. I do have 6 and I have 2 to the 5th power. I need to deal with that 2 to the 5th power first before I can combine these. Now 2 to the 5th power, and just so I'm saying it in my head, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. All right, so this is really plus 6 plus 32. That's really what's happening there. So let's simplify that one out. 6 plus 32 would just be 38. So here's, I have 4r to the third minus 4r to the second s plus 38. Let's check degrees. The first term is to the third degree, the second term is also to the third degree, and the last one is to the 0 degree. So we are done with this problem as well. So did I check everything off to show, did I use my order of operations in space? Yes. Did I identify like terms and add the coefficients, leaving the variables alone? Absolutely. That's what the color coding shows you. You can see where my like terms are and how I'm just adding the coefficients or subtracting them. And is my final answer in standard form, arranging from greatest to least degree? Yes. All right, that's it, Math Marvels. You're going to do the same thing. Use that checklist to help you. Use the criteria for success to help you. And if you're struggling, ask for that feedback. Say, I need help with this one. I'm not sure how to do standard form, or I'm not sure how to combine like terms. And that way you can get the feedback you need from either your peers or your teachers before the exit ticket. I will see you in the next lesson. Be well.